आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. So today we are going to discuss one question on applications of derivatives. So here in this question we are given a function. So the function is given to us as f of x, and that f of x is represented parametrically as given below. So here we are given the x as equals to the phi of t, and that is given by the t to the power 5 minus 20t plus 7 like this. And here we are given the y as equals to the psi of t, and that is given by the 4t cube minus 3t square minus 18t plus 3 like this. And here t belongs to the interval from minus 2 to plus 2 closed interval. Now in such a case we need to find the intervals of monotonicity, and we also need to find the points of extrema, and after that we need to find the range of this given function. So for finding all of these things we should know the dy by dx, that is the f dash x value. So for that we are going to calculate the dx by dt and then the dy by dt. So here we are going to calculate the dx by dt. So the dx by dt would be equals to, here we have, if we differentiate this x with respect to t, then we get the 5 times of t to the power 4 minus 20. So if we take 5 common out from this, then we get the 5 outside, and inside we are left with the t to the power 4 minus 4 like this. Now we can also factorize it. So if we factorize it, then we get the 5 times of, here we are going to apply the a square minus b square identity. So it would be the t square plus 2 into the t square minus 2 like this. And if we apply further the a square minus b square identity in this bracket, then we get the 5 times of the t square plus 2, and here we get the t plus under root 2 into the t minus under root 2 like this. So this is the value of the dx by dt. So let us say that this is the result one. Now similarly we are going to find the value of the dy by dt. So here we have the dy by dt as equals to, here we differentiate this expression, so it would give us the 4 3 is 12. So here we have the 12t square minus, here we have the 3 2 is 6 times of t minus 18 like this. So now we are going to take the 6 common out from this. So if we take 6 common out, then inside we are left with the 2t square minus t minus 3 like this. Now for solving this we are going to factorize it. So for that we have the 6 times of, here we have the 2t square, and instead of this minus t we are going to write the plus 2t minus 3t. So here we have the plus 2t minus 3t like this. So now we are going to take the 2t common out from these two terms. So from these we get the 6 times of, here we have the 2t outside, and inside we are left with the t plus 1. So here we have the t plus 1, and here we have the minus 3 common outside. So after that we are left with the t plus 1 like this. So from this we get, here we have the 6 times of, here we have the t plus 1, if we take it common, and inside we are left with the 2t minus 3 like this. So this is the value of dy by dt. So let us note this down here. So we have the value of the dy by dt as equals to the 6 times of the t plus 1 multiplied by the 2t minus 3 like this. So let us say that this is the result 2. Now from this we are going to find the value of the dy by dx, that is the f dash x. So from this we get the value of the dy by dx, and that would be the dy by dt whole divided by the dx by dt. We can write it like this. So the dy by dt is equals to, by this equation 2 we have that. So here we have the 6 times of the t plus 1 into 2t minus 3, and this is whole divided by the dx by dt, that is this expression. So here we get the 5 times of the t square plus 2 into the t plus under root 2 into the t minus under root 2 like this. So this is the value of the dy by dx. So let us say that this is the result 3. Now here we have got the value of the dy by dx, and the dy by dx is equals to the f dash x, we know that. So now from this f dash x function we are going to evaluate the critical points. So we know that the critical points are got when we put the f dash x is equal to 0. So if we put the f dash x is equal to 0, then we get the critical points as, the critical points would be, here we have from this first bracket we get the t is equals to -1. So we have the t is equals to -1 as one critical point, we get the 3 by 2 from this bracket. So we get the 3 by 2 as another critical point. From this we get the t is equals to minus root 2, and from this we get the t is equals to plus root 2. So the plus minus under root 2 are two more other critical points. And from this we know that the t square plus 2 will always be going to be positive. And since this is always going to be positive, so this will not affect any nature of increasing or decreasing functions, or it will not affect any monotonicity of this function. So we are going to neglect this. So here we have got the critical points as the minus 1 minus plus 3 by 2 plus minus under root 2, like this. So here we have got the 4 critical points. Now in the question they have given us that the t belongs to the range of the minus 2 to plus 2 closed interval. So now we are going to write the points of extrema. So we know that the points of extrema would include the minus 2 and plus 2 because they are the extremum points, and along with this the points of extrema would include those points at which the function derivative changes its signs, that is a critical point. So from this we can say that the points of extremum, the extremum points consist of the t is equals to minus 1, minus 2. So here we have the extremum points as the t is equals to minus 2, then we have the t is equals to minus 1, then we have the t is equals to minus under root 2, then after this we have the t is equals to the plus under root 2, like this. Then after this we have the t is equals to 3 by 2, and after this finally we have the t is equals to plus 2. So these are the extrema points. So this is one part of the solution which was asked to us in this question. Now after this we are going to find the monotonicity intervals. So for that we are going to draw the number line here. So let us say that here we have the number line like this. So here we have the number line like this. So this is our number line. Now on this number line we are going to plot all these points of extrema. So here we have the t belonging from the minus 2 to plus 2. So here we have the extremum point as minus 2, and here we have the other extremum point as plus 2, and in between these 2 points we are having these 4 points. So here we have the minus 1, we also have the minus under root 2, then we have the plus under root 2 here, then after this we have the plus 3 by 2. So here we have the 3 by 2, like this. So here we have got all of our 6 extrema points. Now here we know that to the right of the rightmost critical point, by using the wavy-curvy method, to the right of the rightmost critical point we always have the positive sign. So here we have these 4 as the critical points as we evaluated here, and to the rightmost side of the rightmost critical point we have the positive sign. So here this function, the f dash x, would always be going to be positive, and at t is equals to 3 by 2 it is negative. In this range it is positive, negative, positive, like this. So we can also check these ranges in for example in the range 3 by 2 to plus 2 we have this complete expression as a positive expression. We can cross check that. So by using the principles of the wavy-curvy method we have got this range. Now here in this range from 3 by 2 to plus 2 we know that the f dash x is always going to be positive because here we have the positive sign. So in this range from 3 by 2 to plus 2 this is going to be an increasing function, because when the f dash x is positive the function is always going to be increasing. So here we have the increasing function, monotonically increasing function. In the range from plus under root 2 to 3 by 2 we have the decreasing function because here we have the minus sign for this f dash x function, and in this range from minus root 2 to plus root 2 we have the increasing function, here we have the decreasing, and on the similar basis here in this range from minus 2 to minus 1 we have the increasing function. So here we have the monotonically increasing function as the monotonically increasing nature. Now here in this range from minus 2 to minus 1 we can say that our f dash x function is always going to be positive function because here we have the positive sign. Now since we know that whenever our f dash x is always going to be positive, then our function is always going to be the monotonically increasing function in that range. So here in this range from minus 2 to minus 1 we have the monotonically increasing nature, and in the range from minus root 2 to plus root 2 we also have the monotonically increasing nature, and in this range as well, that is from 3/2 to +2, we also have the monotonically increasing nature. Now let us check where this function is always going to be monotonically decreasing. So this function is going to be monotonically decreasing nature in this range from -1 to -√2. So here we have the range from -1 to -√2 union. Here we also have the range from +√2 to 3/2. So here we have the +√2 to 3/2. So this is the range when the function is going to be monotonically decreasing, and this is the range when the function is going to be monotonically increasing. So they have asked us in the question that in which range the function is monotonically increasing or decreasing, that is the intervals of monotonicity. Now at last they have also told us to discuss about the range of the function. So now we are going to discuss about the range of the function. So for the range they have given us the value of the y as a psi of t. So now for the range we are going to consider this function, that is the 4t cube minus 3t square minus 18t plus 3. So let us note this function down. So here we are given the y as equals to, we have the 4t cube minus 3t square. So here we have the 4t cube minus 3t square. After this we have minus 18t plus 3. So here we have the minus 18t plus 3 like this. So this is the function y. Now we are going to find the functional value of this function at all of these points of extrema. So from this we can comment what is the maximum and the minimum value of this function. So let us first consider the t is equals to -2 point. So at t is equals to -2, we can find the y of -2 as equals to, here we have the 4 into, here we have the -2 cube, that is the -8. So here we get the -4 into 8 minus, if we put -2, then we get the 3 into 4. So 3 into 4 is 12. So here we have the 12, and if we put -2 here, then we get the 18 into 2, that is 36. So here we get the 36 plus 3 like this. So if we solve this, then we get -5. So on solving this we get the y of -2 is equals to -5. Now after this we are going to calculate the functional value at the t is equals to, here we have the second point as -1. So here we have the y of -1. So that would be, here we have the -4, the -3 plus 18 plus 3, and on solving this we get the value of y of -1 as plus 14. So here we have got the y of -1 as 14. After this we are going to find the y of -√2. So here we have the y of -√2. So here we have the y of -√2 as the 4 into -√2 whole cube. So that would be the 2 into √2 with the minus sign. So here we have the -2 into 4, that is 8 under √2. And if we put the -√2 in this square, then we get the square of the -√2 as the 2. So 2 into 3 is 6. So here we have the -6, and here we have the -18 into -√2, that is the plus 18 √2, and here we have the plus 3. So on solving this we get the plus 10 √2, and here we have the -6 plus 3, that is the -3 like this. So we get the 10 √2 minus 3 as the y of -√2. Now after this we are going to calculate the y of plus √2, because that is the next extrema point. So y of plus √2 would be, here we have the 2 √2 into 4, that is the 8 √2. So here we have the plus 8 √2, and here we have the √2 square, that is 2 into 3, that is 6. So here we get the -6. Here we get the -18 into √2, that is the -18 √2, and from this we get the plus 3. So if we solve this, then we get the 8 minus 18, that is -10 under √3, sorry, under √2. So here we have the under √2, and here we have the -6 plus 3, that is the -3. So from this, if we solve this, then we get the minus times of the 10 √2 plus 3 like this. So this is the functional value at t is equals to √2. Now the next point is the plus 3/2. So here we have the next point, the next extrema point as the plus 3 by 2. So we are going to find the y of 3 by 2. So for that we have the 4 into the cube of 3 is 27 divided by the cube of 2 is 8 minus 3 into the square of 3 is 9 divided by the square of 2 is 4 minus 18 times of, here we have the 3 by 2 plus 3 like this. So here we get this 4 getting cancelled out with this 8. Similarly here we have the 2 getting cancelled out with this 18. So if we solve this, then we get the 27 by 2 minus, here we have the 27 by 4. Here we have 9 3s are 27 plus 3. So after solving this we get, here we have the 27 by 4 from these two first terms, and here we have the minus 27 plus 3. So from this if we take the minus 27 common, then we get the 27 times of 1 minus 4, that is minus 3 by 4. So here we have the minus 3 by 4 like this, and here we have the plus 3. So on solving this we get it as the minus 69 by 4. So this is the value of the y of 3 by 2. Now at last we are going to find the value of the y of 2, that is the last extrema point. So here we have the y of plus 2, and that would be equals to, here we have the 4 into 8. So the 8 4s are 32 minus, here we have the 3 into 2 square, that is 4. So the 4 3s are 12, and here we have the minus 18 into 2, that is minus 36 plus 3 like this. So if we solve this, then we get minus 13. So here we have got the y of 2 is equals to minus 13. Now in the question they have asked us to calculate the range in the final part. So now we are going to calculate the global maxima and global minima, and that will give us the range. So here we have the minus 5, here we have the 14, here we have the 10 root 2 minus 3. So if we calculate it, then it would be around 11.14 like this, 11.14, and here we have the 10 root 2 plus 3. So it would be 17.14 with a negative sign. So here we have the minus 17.14 like this, and here we have this result as minus 69 by 4. So if we calculate the minus 69 by 4, then it would be equivalent to the minus 17.25. So here we have the minus 17.25, and this is minus 13. So here we have the minimum value as the minus 17.25, that is the y of 3 by 2. So this is the point of global minima. So this is the point of global minima, and now we are going to find the point of global maxima. So the point of global maxima would be, here we have the 14, here we have the 14. So 14 is the point of global maxima. So this 14 is the point of global maxima. So we have our range of this function as, the range of this function would be, here we have from minus 17.25 to this 14. So here we have the range from the minus 17.25 to 14. So this is the range which was asked to us in the question. So at first they asked us about to calculate the points of extrema. So here we have the points of extrema. Then after this they asked us to calculate the monotonically increasing range and the monotonically decreasing range. So here we have the monotonically increasing range, and this is the monotonically decreasing range. And at last they also told us to calculate the range of this function. So here we have the range of this function is this. So this is our solution. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।